Hey folks, Mr. Dell here. We are looking at um, exponent expressions, rewriting them so that way they are simplified and there's no negative exponents. So this is coming from CPM's Math 2, Integrated Math 2, and this is section 6.1.2. Specifically number 6-21. So it says rewrite each of the expressions below. Your final expression should not contain negative exponents or parentheses. So there's three different types of problems here. So there's three rules that are applied. First of all, with this one here with A, if you notice it's 5 times x to the third, and then all of that times negative 3x times x to the negative 2, right? So we know this is a string of multiplication. So it's really 5 times x to the third times negative 3 times x to the negative 2, right? And when I have multiplication, nothing but multiplication, I could use the associative property of multiplication or commutative property multiplication to kind of move things around and multiply out of order, where I can take 5 times negative 3. That's the first thing I can do is put those together because those are the coefficients and they'll multiply together. And then also times x to the third times x to the negative 2. So those are like bases, so I want to multiply those. So first of all, 5 times negative 3 is negative 15. X to the third times x to the negative 2 is actually just an x to the positive 1 or x to the first. And so there's my final answer. So let me explain why that's the case. So you have exponent rules. There's some exponent rules to remember. One of the rules is to say that you would have x to the a times x to the b. If I multiply like bases, my bases are both x, then my base stays the same and all I do is add the exponents. So that's one of the exponent rules. So if you notice here, it was a 3 and a negative 2. So 3 plus negative 2 is just 1. So really that you could put the little 1 there, or the 1 doesn't need to be there and it means the same thing. Okay. Next one. This rule is my power to power rule. So I'll just show you the rule real quick before I do the problem. If I have a base to an exponent, so x to the a, and then I take all of that to another exponent, so power to power, exponent to exponent, what we get is the base doesn't change, and I multiply the exponents, a times b. So x to the a, all to the b is the same thing as x to the a times b. So here's my power, and here I've got all of these. So all of this needs to be to the third power. So it is currently a 4 to the first, right? When you don't have an exponent listed, it's always a 1. So 4 to the first now becomes 4 to the third because 1 times 3. It was a p to the second. Now it becomes p to the sixth because it's 2 times 3. It was a q to the first, and now it becomes q to the third because of the 1 times 3. You're distributing that to each of the powers themselves, power to power, and you multiply. So when you have a power to power, you multiply the powers. Okay. So finish this one more thing. 4 to the third means 4 times 4 times 4, which is 64. So p to the sixth, q to the third. So there's my final answer for that one. This one here, we have another rule. Another rule happens to be if I take like bases, in this case, x to the a over x to the b, if I'm dividing them, if I have them written as a fraction, a ratio, division, then the base stays the same. It's still x, but what do I do with the exponents? I subtract them. A minus b, the top minus the bottom, a minus b. So here, first of all, I just have the 3. That's not changing because it's 3 divided by 1. I divide the coefficients. But in this case, it's m to the what now? So instead of the 7 and negative 1, I have to take it and I'll write it out, 7 minus negative 1, right? I'm subtracting those exponents. So my final answer would be 3m to the 8. 7 minus negative 1 is positive 8. So there's that answer. All right, there we go.